All right, folks, the goal of today is to talk all about transformations. We're going to take what we learned last time with our parent functions and talk about the different things on a graph that we can do to each of those parent functions to come up with new equations. Our focus for the first half of this is going to be only on translations. Okay, so that's a shift left, right, up, or down on a graph. And part of this is going to be a little bit familiar from what you learned last year in Algebra 2. So we're going to start out with taking kind of your purple note card idea and getting rid of all the things that don't deal with translations. So our translations are H and K. Remember, H is your horizontal, it's left and right. Notice it's grouped in with X, just like X is left and right on a graph, so is our H value. And then our K is going to be the vertical translation, that'll be up and down. When we think about direction, though, because the H is the horizontal translation and this says minus H, we always see the opposite of what is actually happening on the graph in the equation. So if we see a minus 4, that'd be to the right 4, and so on. Because this said exactly K, we're adding that K value, what you see is what you get in terms of the vertical translation. What's new is we're going to talk about what's called the translation rule, and this kind of gets confused a little bit with the T of XY from purple note cards. Not the same thing. Okay, this rule, that XY is talking about an ordered pair, and it allows us to talk about the translation for any ordered pair on an original parent function. How that works is, you'll notice on this right-hand side it says take the X value and add H, take the Y value and add K. This is a formula for finding the image or the result of a point underneath some sort of transformation, in this case a translation. This is going to be very powerful for getting ordered pairs really quickly without necessarily having to use the new equation. So what we're going to do to start out with is just practice going from one form to the other. Notice it's got the equation here. We've got a parent function. We'll practice with this one. Our parent function just strips down all the extra junk, leaving just our y equals x squared. And our rule allows us to take this minus 3 and this plus 7 and tell what they do on a graph. So you'll notice it starts with T of XY. The T is for translation. That XY is going to start out with always. And then what we're going to do is write a big ordered pair that's been changed. So instead of XY, we're going to have something dealing with these numbers on the inside. And the relationship is just exactly opposite. I'll flip back here real quick. When we see a minus H, we'll write plus H on the rule, and vice versa. They just flip-flop. Whereas the K stays exactly the same. The rule tells direction on a graph. So when we see a minus 3, we know that's right on a graph. That would mean take the X value and add 3. We think about starting at 0, 0 to add 3 literally moves it to the right because I'm at 3 instead of 0. Similarly, we're going to talk about Y. So we've got our Y to start with. Remember, K is what you see is what you get. It stays exactly the same for the rule versus the equation. And that's it. Okay, but I want to talk about what this actually means. So on your paper it says, if we take a point on the parent function of y equals x squared and run it through this rule that we just came up with, the image or the result is going to be a point on our transform equation or on this equation that we were given to start out with. So here's how it works. I have written out the table for our parent function, y equals x squared. So I literally just pick some x values, some negative, 0, and some positive, and then squared them because our parent function is the parabola. So then if you look at these ordered pairs, what we can do is we can run them through the rule because each of them have an x and a y value. So what that would look like is you take your ordered pair and you plug it in for this x and this y, so the negative 2 would go there, positive 4 would go there. So I've got a negative 2 plus 3 is positive 1, 4 plus 7 is 11. And I can do that with each of these ordered pairs. So these column, or this column of numbers here, is representing points that are on this equation. And just to show you that works, what I did on this last little t-chart here is I wrote the equation for the given one we're looking at here, and then I picked some x values again. And because I started with -2 again, this ended up just plugging it in here. -2 minus 3, -5 squared is 25 plus 7 is 32. I just went down the row until I saw some of this repeated values. And you'll notice we've got 111 that corresponded to the original -2, 4. And then if I were to continue this pattern, you'd end up seeing the rest of these values. And the problem with that is, well, not necessarily a problem, but here it was a little bit more work to come up with that number 32, whereas this one, all you had to do is add. With a rule and a translation, you're just adding or subtracting, and it makes this really powerful for us because we can get the transformed points really quickly using it. So we're going to go the other direction on this next one. We're given the rule and we're given a parent function. Generally, when you write these, I don't necessarily care if you use f of x or y, so whatever you like better there. But we're going to have, instead of the x, we'll put something with the numbers that we have here. So you'll spread it out just a little bit, and then we're going to copy this power for our parent function. And even though we're starting with the rule this time, the pattern still stays the same, no matter what the direction. So we're going to take what we see in the first part and just switch it. So we see an x plus 4, we're going to write x minus 4. This minus 3 just goes on the end. Second part doesn't flip. And then it says 2, 8 is on the parent function, this x cubed. Notice if you take 2 and cube it, you get 8. We want to know the image of this point under the translation. The rule is the easiest way to do that. We're going to take our x value and put it right with the x there. Take our 8 value, do the same thing with y. So then 2 plus 4 is 6. That's the new x value. And then 8 minus 3 is 5, and we're good to go. Just to show you this actually works with our equation, we've got this x value here. 6 minus 4 is 2. 2 cubed is 8. 8 minus 3 is 5. It corresponds to the equation as well. What I want you to do now is pause the video and see if you can handle 3 and 4 based on what we just took care of with 1 and 2. You should have gotten f of x equals, inside the absolute value is an x minus 8, outside is a minus 10. On this one, you do have to, with a rule, start with t of xy. So if you missed that on the first one, or first try, go ahead and fix that for me here. And it's just going to look like a big ordered pair. You'll notice on this one, our x is up in the exponent. Anything that deals with horizontal or left and right on our graph is going to show up here. So that includes our translation. We see minus 3, so we're going to write x plus 3. And then second thing, we'll put a y in front, but that minus 5 just comes along for the ride. Next up, we're going to talk about graphs and making sure we can write rules and equations from them. So you'll notice over here we've got this V shape. That's our y equals absolute value parent function. And it says find the rule that would make 0, 0 go to 1, negative 3. So that tells us direction. We're starting at this 0, 0 and going to that other one. The rule, remember, starts with t of x comma y. And it looks like an ordered pair after that. So we want to know what is happening with the x values. We can look literally at the numbers here, or we could look at the direction. But to get from 0 to 1, you take the x value and add 1. Or we go to the right. Remember the rule, what you see is what it does. Then, similarly, to get from 0 to 3, you take the y value and subtract 3. Or we're going down 3 on the graph. Then it's in our parent function that that first part actually switches. So we've got y equals, and inside it'll be x minus 1, and then our minus 3 on the end. Okay, this definitely says go to the right one from what you learned last year, and we've got that happening on our graph. Then it wants us to find the image of this point. Again, use the rule. It's the easiest way to go about this. We're putting a -2 there. We're putting a +2 there. And just simplifying. -2 plus 1 is -1. 2 minus 3 is -1. And that's it. If you look on the graph, I want to show you how this works. The -2, 2 was this point. And our rule said go to the right 1 and then go down 3. 1, 2, 3. Here's our new point. -1, -1 is exactly what we came up with. Alright, what we're going to do on the back side is talk about purple note card stuff. It is not the same as Algebra 2. There are some new things you're going to see and some adjustments. So in order to take care of this, we need to know what all of our parent functions look like. I left out the greatest integer function or step function on purpose. We'll talk about that next time. The rest are here. I want you to pause the video and sketch each of those for me. We need practice with this so we know what we're doing without a calculator. Here's what you should have come up with. We do care about the important points or features of the graph. So 0, 0 shows up on a lot of these. On ones that don't have it, it's because there are asymptotes in place. So the inverse has 1 at x equals 0 and y equals 0. Exponential just has y equals 0, and that moves our intercept up to 0, the a value, whatever that may be. And then our inverse square again at 0 and 0. So get those details labeled on there if you missed them the first go around. But what we're going to do is use this and talk about how this looks a little bit different from what you talked about in Algebra 2. So check out your note card. Under Chapter 3, you've got transformations of graphs that look like this. At the very top here, you've got a generic equation. These grouping symbols are going to be adjusted depending on what our parent function looks like. We're going to see a lot of different parent functions that you haven't worked with before, not in terms of these transformations at least. First step is still reflection of the x-axis. We're looking if there's a negative on the outside of whatever our grouping symbols are. Dilation comes next. That's a big change. You didn't have to worry about order of operations last time because a lot of the ones we did when we were talking about this HK came from the point 0, 0. And when we're talking about a dilation, that's really multiplying by some number. When you multiply 0 by something, it stays 0. So the order of these items didn't matter. But because we're going to be talking about some other graphs that don't have 0, 0 on them, it's really important that we pay attention to this order and do it the right way. So we're starting out with dilation, okay, and we'll talk about these details in more clearly when we get to examples, but what you need to know for right now is the A and the B values are going to represent some sort of dilation. Okay, essentially it's the numbers that aren't translations, aren't being added or subtracted. And then finally, reflection over the y-axis is if you have a b value, so that's negative on the inside of our grouping symbols. And these are going to be a little bit weird in general, so we'll pay attention and be careful when those happen. Alright, so on 6 through 11, here are the steps I want you to follow. First up, I want you to strip down your equation and leave only only the important parts of the parent function. So ours has this x in the exponent, so I know it's going to be y equals something with an x power. But remember, we talked about this just briefly. With the parent function of an exponential, the base has to be included. This is not the b from the purple note card. It's b as in the base, and that's the number just closest to it. If you do see a b value from purple note card idea on this, it's going to be in front of the x. Okay, everything this bx minus h is going to be the same place your x falls in your parent function. Next thing I want you to do is do a sketch of whatever that looks like before any of the transformations happen. So this one here, 2 to the x is growth. So start low, go high. And we have y equals 0 being the asymptote for this exponential. What we're going to do is take this and adjust it based on the different transformations that are happening. The goal for me on this is the sketch. So we're still going to do the 1, 2, 3, 4 to talk about these transformations, but we're going to abbreviate a lot here because we're just going to use these to be able to graph whatever this looks like. So going in order, our first thing we're looking for is if there's a negative on the outside of our grouping symbols. They have our parentheses for us, so that's good. This negative means we have a reflection over the x-axis, and I like to abbreviate that just Rx. Second step is a dilation. It's a number that's not a translation, and for us that 3 is a dilation. We just have to figure out what type. So now we'll go into detail about our different types of dilations. They're going to be grouped by 2 different types. One is a vertical something, so this S stands for a vertical stretch, and this C is a vertical compression. Second part is horizontal something, again horizontal compression, horizontal stretch. If we're dealing with an A value, it's on the outside, so that is a vertical something. If we're talking about the B value, it's inside and it's horizontal, just like we talked about with the H's going left and right, just like the X's. Horizontal goes in with it. So what we're going to do, because this is on the outside, is look at A, and it's got this 3 value. The negative we've already taken care of, but it also does say absolute value here. The number 3 would be greater than 1, so this is a vertical stretch. So we've got a vertical stretch by a factor of 3. Okay. Our next step is talking about the translation, and we'll use a capital T and then give the H and the K value. So an H value is going to show up where X is. We don't have anything, so that's 0. And then a K is usually to the side. So 0, 7. And then finally, we're looking for a negative value on the inside of our, or with our X value. In this case, that's in our exponent, and we do not have one. So what we're going to do using this sketch that we did is run through each of these steps in order, making sure everything's taken care of. So I want you to draw a big X and Y axis here. This is our meat of our problem, so it should take up all of our room here. First up, we are going to talk about the critical features. So that's going to be the point or the asymptote. So we have an asymptote at y equals 0. We're going to always take care of that first. If we reflect that over the x-axis, it stays the same since it's on the x-axis. Vertically stretching it won't do anything either. The only thing we have to do is take care of this translation. Since this is a y value, we go up 7, and that puts us on 7 itself. So I want you to dash that on there with a y equals 7. Then we're going to take and talk about the shape of this thing. So when we look at the shape of this thing, there's one important feature, and that was the 0a that it goes through, and it kind of guides us on how our curve actually is drawn. So what we're going to do is figure out our a value from our original equation. Remember, it's the thing out front, so that's -3. So we're starting at 0, -3. But it seems a little bit far away from this asymptote. And the reason that is because we still have to go through our steps. Taking and using A actually skips over these 2 steps where we only have to talk about the translation. Okay, because that negative comes from the reflection and the 3 comes from that step 2. So those are already done. We just have to translate. So I'm taking my -3 and shifting it up 7. Okay, I'm going to actually write this out so you have an idea of what we're doing here. But 0a for us is 0, -3, and we're translating that through our rule. We said our rule was take the x value, which was 0, and add 0 to it. Then it said take the y value, which was -3, and add 7 to it. So that our new point should be at 0, +4. Essentially, we're taking -3, adding 7, here we are. Then we want to talk about this shape. being reflected over the x-axis, so this tail would stay still close to the asymptote, just on the other side, but instead of going up forever, it's going to be reflected down forever this direction. Okay, so we are starting at our asymptote, going through the point, and then going down from there. And there's our graph. Next one is same process. First thing you're going to do is strip it down until you just have the parent function, y equals x cubed. And then you're going to sketch what that looks like. A cubic starts low and goes high, and goes through our origin of 0, 0. Notice we don't have any grouping symbols here. When we're talking about exponents, only the thing directly next to it is getting taken to the power unless otherwise stated. So they didn't give us parentheses, which means x is the only thing getting cubed. We're going to show that anytime there aren't parentheses, you're going to add them directly left and right of x. Nothing else should be included. So you'll just hug that x. With that, we can do our steps knowing exactly which are a values and which are b values as we go through here. So because this is now outside, it is considered an a value, which means a reflection over the x-axis. Our dilation doesn't exist because there are no values other than the translation. Speaking of translation, there's nothing inside with the x, but there's that -4 on the outside. And then we already talked about that negative, so we're done there. Draw yourself a big x and y axis. And we're going to start with this point 0, 0, just like we started with the asymptote over there. So 0, 0, we're running through our rules here. Reflection doesn't change anything because we're at 0. We just have to go down 4. So go ahead and label that 0, -4. And then because we've taken care of that, we're on to the shape. So if we think about this shape, step 1 says we reflect it. Reflection over the x-axis, y'all, just means flip it, where if you are increasing from left to right, you'll then be decreasing from left to right. Okay, so this part actually goes up, and the second part actually goes down. So instead of going up, we will go down through our point. And we already took care of that translation, so you just have to make sure that the middle of your curve there lands on the point. And that's it. Next example, we've got a parabola. So y equals x squared is the parent function. And because it's a parabola, we're going to make that shape. And make sure we know that that was 0, 0 to start with. Numbering our values, 1, 2, 3, 4. We want to talk about all these steps. So first step, we already have grouping symbols. We're looking for a negative outside. That's not happening for us, so you can just cross it out. Second step, we're looking for a dilation or a number, not a translation. So that would have to be this number 4. Since the number 4 is inside, it's considered a b value, which goes with horizontal something on the graph. And the number 4 is greater than 1, so it'd be considered a horizontal compression. Now what we have to pay attention to with anything horizontal, doesn't happen with vertical, it's just horizontal, is you have to pay attention to the parent function. Because this 4 is inside that grouping symbol, meaning that 4 cares about what the grouping symbol does to it. So this 4 is getting squared, which means our horizontal compression is really by a factor of 16. On step 3, we're back to translation. There's nothing with x again. We do have a -2 for our y translation, or a k. No negatives though, so we don't have a step 4, and we are on to our sketch. Draw your x and y axis for me, and let's go to work. We're starting with 0, 0 again, running it through our steps. Horizontally compressing doesn't do anything to the number 0, but we do have to go down 2. Go ahead and label that for me. And then we'll talk about shape. Normally my parabola goes up. I don't have a reflection, so it stays that way. But we're taking horizontal, which is left to right, and we're squishing it. Okay, it says compress it. So when you take this left and right and you smush them, it actually gets skinnier. So we're going to draw our U just a little skinnier than we normally do. Okay, and that's it. Next up, we're talking about our hyperbola. If you take those extra numbers off, we're left with y equals 1 over x. I do want to point this out. The a value, if there is one other than 1, is going to show up on the top here, since this is a new parent function that you haven't really worked with a whole lot. And then our k and h, very similar to what we have been doing. H is always going to be next to x, k is going to be to the side. Okay, so nothing new there. What is new is what our graph looks like. Okay, we want to make sure that we know all the details. This is the one that has some asymptotes at x equals 0 and at y equals 0. And then we've got our curves in diagonal quadrants. So we're going through our steps here, and we're keeping in mind that we don't have an intercept, we have asymptotes instead. Step 1, because this a value is 1, we don't have negative values, no reflections. Dilation, the 2 and the 6 are translations, so we don't have either of those. With our translation, -2 means +2. That's the first time we've seen an h value so far today. And we remember from the front side that we need to switch it. The 6 just comes down, and we're done with this in terms of the steps. Go ahead and draw your x and y axis on so we can talk about sketching the transformation here. Because we don't have 0, 0, we're going to literally transform those equations of the asymptotes. So x equals 0 has to go through the translation that affects x, and that's just this number 2. So that means to the right 2, I'm literally at x equals 2. Very similarly with the asymptote 0, we're going up 6 so it stays on 6, and we're drawing that one on there as well. And that's y equals. And because the translation was the only thing on my graph, I just have to copy my curves where they're supposed to land. Okay, so we're using the asymptotes to guide us. Start at the asymptote and end there. And then we're doing the same thing diagonally. And that's it for that one. Couple more for practice here, and so we can see something new from last year other than different parent functions. Okay, so we've seen this parent function for a while, y equals absolute value of x, and it makes the shape of a v starting at 0, 0. What's new, though, is you've actually never seen a b value happen at the same time as an h value. This will be the very first time. And because of that, you haven't really learned how to handle those two at the same time yet. Okay, so go with me here. First step, nothing new. There's no negatives out front. Step 2, nothing new. We're going to look at this 2 value. Because it's inside, that means it's a horizontal something, and because it's larger than 1, it's horizontally compressed. We learned last time we want to make sure that we are paying attention to parent function with horizontal. It just says absolute value of 2, so this one really is just 2. Okay, what's new is the translation is not -8. Because I want to take some time here to talk about where translation actually comes from and why it moves the important point to where it actually looks the opposite of what you see. This point 0, 0 comes from taking the absolute value of 0 gives you 0. Well, we know we have some more things going on here, but the whole idea is still to get whatever that's inside to be the absolute value of the number 0. So how that looks is you're taking 2x plus 8 and you're setting it equal to 0. So 2x equals -8, and then x equals a -4. So my translation is not a -8, it's actually a -4. And it's all about order of operations with the dilations and the translations here. So if you have B and H, you got to be careful on step 3. Alright, well, if that makes this go to 0, then 0 plus 5 is still 5. You don't have to worry about the y value. Okay, notice, just to show you again, 2 times -4 is -8. -8 plus 8 is 0. That's gone. Then you're plus 5. And then we don't have a reflection over the y-axis. Let's sketch this one. Parent function usually starts at 0, 0. We are compressing it, stay 0, 0, then left 4, and up 5. Horizontally compressing again gets skinnier, so we make a slightly skinnier V going up, and we label our point. Next up, we've got y equals the square root of x. Usually starts at 0, 0 and heads to the right and up after that. I want you to pause the video and try this one on your own. Alright, we've got a lot going on here. Reflection over the x did happen. We do have a horizontal compression again. Hopefully you caught that that's the square root of 3, not just regular 3. Parent function matters. And then our translation, this is another one. Because there is a B and an H, you have to just set that thing equal to 0 to figure out the translation. So x would be -2 over 3. You don't have to worry about that with y. As long as you work hard for the x, the y value is still that thing to the side, and there is no reflection over the y-axis. Going through here, we're taking our 0, 0 and running it through the steps. The only one that is going to affect 0 is this one here. We're going left 2/3 and down 1 and labeling it. Then our reflection is going to, again, instead of going up, we're going to end up going down. So it's got a negative little curve here. And because it's horizontally compressed, that would just mean that this actually looks like it's steeper. And there's our curve. I'm going to talk for this one just for a bit. A lot of the purpose of being able to sketch these is so we can answer questions about domain and range super quickly. Our domain here for this graph would be starting at -2/3 going to infinity. And the range, because of the reflection, actually starts at -infinity and goes up to -1. Okay, using that endpoint, we can figure that out. Last thing we're going to do is work backwards, and these in general go quicker. We do have to watch for that B value and H that happen at the same time on occasion, but otherwise, here's kind of what we're going to be looking for. First thing we're going to do is write the generic function for all of these, and we're going to adjust it based on the parent function. So our generic function starts with A, and then it's bx minus h inside. And we're using absolute value because they did. And then plus k on the outside. From there, we just have to know what the a, b, h, and k mean in regular words. So a is going to mean two different things for us. It's going to be a reflection over the x-axis, but it also represents a vertical something or other. B value is going to be a reflection over the y-axis, if there is one, and it will be a horizontal something or other. H and K are both going to be talking about translations of some sort. H specifically is for left or right, and K is when we see something about up or down. So we'll just read through and put our numbers underneath each of the variables they correspond with as we go through here. So it says the graph of y equals absolute value of x has been translated 4 units to the right. If we want to go right, we say minus 4. Then it's been vertically stretched by a factor of 2. Vertically, you don't have to worry about. It just goes outside. Then it says reflect over the x-axis. Remember, again, that is also outside. So we put a little negative there. And then it says shifted 3 units down, so minus 3 on the edge. Because b wasn't mentioned, that means it gets to be left out. It's really 1, but we don't need to write it. And that is all you have to do. Next one, we're going to start out and take our grouping symbols and square them. So x minus h inside, squared outside with the plus k. And it's the same process. Shifted 3 units to the left. If I want to go left, I'm going to say plus, this might be there, I'm going to say plus 3. And then it said reflected over the y-axis, so the y actually goes inside here. And then it said shifted 2 units upward, plus 2, and vertically compressed by a factor of 2/3. So I'm going to bring this over a little bit, give myself some space, close in some of this stuff, and I can go ahead and put that 2/3. Remember, vertically it doesn't matter about parent function, no worries. But what we want to double check here is that what we said happened was supposed to happen. And I told you if there's a b value and h value, you have to be careful. It didn't say horizontal something, but it did have a reflection over the y-axis, which means we want to double check this. And we're going to do it the same way we did it when we were going the other direction. All you have to do to figure out this is make sure this does what it actually says is supposed to happen. So negative x plus 3 is supposed to tell me going to the left. So right now, negative x equals negative 3, x equals 3. This tells me my x value should be on 3. Okay, but I want to be careful on how this works. Order matters in terms of how you wrote your sentences in Algebra 2. We're not writing sentences, so you just have to make sure you're careful here when you're interpreting this. It says that we are shifting to the left first. So that would mean instead of 0, 0, I went to the left. Okay, I'm going to ignore this vertical for now. It's just to talk about this part. Then it says reflected over the y-axis. Well, when you take this and reflect it over, you do end up at x equals 3. So because of how this is written, and it's written in the right order, this actually works, even though it didn't look like it would. Last one here. Graph of y equals x squared has been horizontally compressed. Factor of 25 reflected over the x-axis and translated 9.9 upward. So starting with y equals a outside, b x minus h, close it, square it, and then we want to make sure we put that plus k on the end. So horizontally, we've got a b value. We're going to watch out again. And it says horizontally compressed by a factor of 25. So I need this number squared to be 25. It means I've got to put a 5 here. Then it says reflect over the x-axis. That's a negative on the outside. Go ahead and close that, or open that parenthesis there. And translated 9.9 units upward. That's our k value, so plus 9.9. Bringing down the rest, I've got y equals negative outside. This x gets squared, and I can leave it like that. If you want to call that y equals negative 25x squared plus 9.9, that would also work for me. I like seeing the parentheses when I want to talk about horizontal, but as long as you know those are equivalent, we're all good. There are a couple on the homework that are tricky with writing these backwards, so if you do have any trouble with those, please feel free to reach out.